So what mass of carbon dioxide forms when 95.6 grams of C3H8 burns? So first thing I'm going to do, I'm going to get rid of things we're not talking about. So, anywhere in the problem does it talk about C3H8? Yes, it does. Does it ever talk about oxygen, O2? If you look through the whole problem, it is only talking about carbon dioxide. It's asking about the mass of carbon dioxide. So that's actually what we're solving for. And we're going to start with 95.6 grams of C3H8. So nowhere does it talk about oxygen. Notice I wrote the question in purple. I'm going to cross out. The only reason I'm doing this in purple is because I don't like to mix markers because it messes them up. So it never talks about oxygen, so I'm crossing it out. It yields 3 carbon dioxides and then 4 H2Os. Does it ever talk about H2O, which is water? No, it does not, so we can cross that one out as well. So if you want to put down at the very bottom, these are just hints, cross out, compounds don't use, or not talked about. Next thing we're going to do is we're going to find all of our different conversions that we will need. So, one of the conversions that we will need is, if you notice, it's talking about 2 different elements, or compounds, excuse me. 2 different compounds. It's talking about carbon dioxide and C3H8. So we're going to have to do what's called a mole-to-mole ratio. And what that is, the mole-to-mole ratio, is you are going to have to look at the coefficient, which is the number in front, of C3H8 and CO2. So these numbers are going to give us the mole-to-mole ratio. So for every 1 mole, since there's no number, of C3H8, there is going to be 3 moles, and we get it from this number, 3 moles of CO2. So that's one of our conversion factors. So if you want to write that down as well, mole-mole ratio. And that is due to the fact, talking about more than one compound. Okay, so that's one of our conversion factors. Another one, notice it talks about mass. Whenever it talks about mass, you have to find your molar mass. So it talks about mass of carbon dioxide, mass of C3H8, so you're going to have to find molar masses. Because it says mass or grams, okay? Either one. And it talks about it twice, so we're going to have to find the molar mass of both of them. You're going to have to watch a different video if you want to see how to find molar mass. But for this, we have, someone used my calculator, that's annoying, 44.009 grams of CO2 for every 1 mole of CO2. So this is one of our conversion factors. It is just the molar mass of carbon dioxide. Now I'm going to find the molar mass of propane. Remember, I'm using these from the textbook, so that might be why I get a little bit different numbers than you. They should be very similar regardless, but they might be off by like 0.01 or something, but they should not be significant. Make sure you are labeling it completely. You need to know which one is talking about carbon dioxide and which one's talking about C3H8. So now I have all my conversion factors. I'm now going to actually start my problem. I'm actually going to do the problem in black. So these are just all the conversions that I will need to get my answer. First thing, sorry, I'm going to label these. So 1, 2, and 3. So we're going to start with 95.6 grams, because this is what the problem tells us we're starting with, of C3H8. So what we're going to do is we're going to pick which conversion factor we must use first. Notice we're trying to get to mass of carbon dioxide, so we have to get rid of grams of C3H8. So we have to go to the conversion factor that has grams of C3H8. Notice number 1 is talking about moles. We do not have moles, we have grams. This is talking about grams, but it's grams of CO2. We want C3H8. Can't use that one. So number 3, notice it has grams of C3H8 in the numerator. We already have it in the numerator, so what we're going to have to do is we're going to have to flip it. That way we can get rid of our grams of C3H8. So we're going to use number 3, but we're going to flip it. So we're going to put 44.097 grams of C3H8 on the bottom. And then on top, we're going to put 1 mole of C3H8. Since we can only use the conversion factor once, I'm going to cross it out to get rid of it. We can also cancel out our units, so we got rid of grams of C3H8. We're now on moles of C3H8. Now we have 2 options. So we're going to look for which one has moles of C3H8. So we're going to start with number 1. Notice number 1 has moles of C3H8, but it's also in the numerator. And this is in the numerator, so we're going to have to flip it so that way they cancel out. So I'm going to put 1 mole C3H8 in the denominator, and then I'm going to put 3 moles of CO2 in the numerator. Moles of C3H8, moles of C3H8, cancel out. We already used number 1. Now we're to our last one, last conversion factor. And we want to get rid of moles of CO2. Notice moles of CO2 is already on bottom, so I'm just going to plug that in, 1 mole of CO2. And then I'm going to put 44.009 grams of CO2. Notice moles of CO2 cancel out. We're left with grams of CO2. This final step, notice we've gotten rid of all 3 conversion factors that we had. This is very important. Check your units. The only ones that shouldn't be crossed out, grams of CO2, should match what you circled, because your circled is your unknown, and it's mass of CO2. They match, so now we're going to multiply all our numerators, and then divide by all our denominators, and that will get us our answer in grams of CO2. So it looks like 286.2 grams of CO2.